Zeros of polynomials. The zero of a polynomial is where the function intersects the x-axis. You can see in the polynomial below that it has 5 zeros because it crosses the x-axis 5 times. Zeros of a polynomial. The number of zeros a polynomial has is the same as the degree of the polynomial. Polynomial can have real, imaginary, or square roots of zeros. The first example you can see is a cubic function, and it crosses the axis 3 times, so it has 3 real zeros. In the second example, it's also a cubic function, but it only crosses the x-axis once. So that means it's going to have 1 real zero and 2 imaginary zeros. The next example, you see a quartic function, and this quartic function crosses the axis 4 times, so it has 4 real zeros. And in the final example, has 4 imaginary zeros because it's a quartic function, but it doesn't cross the axis at any location, so they have to all be imaginary numbers. We have the example f of x equals x plus 5 times x minus 2 squared. This should have 3 zeros because this is a cubic function. There are 3 x terms. But if you look at the graph, it only has 2. The reason behind this is that it does actually have 3 zeros. It has x equals negative 5 from the first term, and then x equals 2 and x equals 2. Since it's x minus 2 squared, there's a repeat 0 at x equals 2. X equals 2 is referred to as a multiple 0 because x minus 2 is a repeating factor. The equation has a multiplicity of 2 because one of the zeros is repeated twice. You can tell if there is a multiplicity by looking at the graph if the function has a max or min at the x-axis instead of crossing through. So it turns around at the axis instead of going right through it. What is the multiplicity of f of x of x minus 3, x plus 1 times x plus 1 squared? This polynomial has 4 zeros. 3, negative 1, and negative 1. So to answer the question, what is the multiplicity of the function? The multiplicity is 3 because x equals negative 1 repeats itself 3 times. Find the zeros of a polynomial function. We are going to use our factoring skills from the previous video to find the locations where the x is going to cross the x-axis. It's going to cross the x-axis whenever y equals 0. So first thing we need to do is we need to set it equal to 0. Then we are going to factor. Factor out the common factor first, so every term has an x, so we can factor out an x. We're left with 3x squared plus 16x minus 12. We can further break down the quadratic into 3x minus 2 times x plus 6. This is a cubic function, so we're going to have 3 zeros. The first 0 is at x equals 0. Whenever you have an x that's a common factor on the outside, if you plugged in 0 here, then the whole entire thing would be 0. The second answer comes from the second factor. If we plugged in 2/3, we would get 0. And the third answer is x equals negative 6. If we plugged in negative 6, we would also get 0. In this next example, we're going to start it off a similar way. We're going to factor out an x first. Oh, excuse me, 2x. Then we're going to take a look at the inside. X squared minus 6x plus 4. Our first answer we have is x equals 0, but we run into a problem because we can't factor the quadratic. So if you can't factor the quadratic, you're going to use the quadratic formula. A is equal to 1, B is equal to -6, C equals 4. When we plug it into the quadratic formula, after we simplify, we get 3 plus or minus the square root of 5. X equals 0 is our first answer, and 3 plus the square root of 5 is our second answer. 3 minus the square root of 5 is our third answer. So those are the three answers for our quadratic polynomial. 8x cubed plus 64. This is the sum of perfect cubes, so we are going to use the sum of perfect cubes pattern to factor the polynomial first. We know that a is going to equal ax and b equals 4. So we use a plus b times a squared minus a times b plus b squared. The first factor term, we can set that equal to 0. So our first answer is x equals -2 because it would make 2x plus 4 equal to 0. The next one, we have to use our quadratic formula skills. And after we plug in the quadratic formula here, we end up with imaginary answers. So our final answer, x minus 2, x equals 1 plus or minus I radical 3. So those are our three answers. So again, whenever you have a plus or minus, that counts for two different answers. If you check out the graph, imaginary answers make sense here because it only crosses the x-axis at x equals -2, which means we're going to have two imaginary answers. The next example here, we have a quartic function, x to the fourth minus 2x squared plus 100. Since it's a quartic trinomial and we only have even powers here, we can use our regular factoring skills. We ask ourselves what numbers multiplied give us positive 100 and add together to give us -29. And the answer here is -4 and -25. Since we want to know where those terms are going to be equal to 0, we can just set them equal to 0. 0 equals x squared minus 4. And if we solve this equation, adding 4 to both sides, and then taking the square root, we get two answers. And those two answers are positive and -2. We're going to do the same thing with x squared minus 25. We want to know when it's equal to 0, therefore we set it equal to 0 and solve. Add 25 to both sides, take the square root. Two more answers are positive and -5. So our four answers for this quartic polynomial, the four zeros, are at +2, -2, +5, and -5. The next example, we're going to start it off in a similar fashion. We are going to factor it by finding the numbers that add up to -5 and multiply give us -6, and that is -6 times +1. X squared minus 6, we want to know when that's going to be equal to 0. Add 6 to both sides, take the square root. We can't simplify the square root of 6, so we just leave it as plus or minus radical 6. As for our other two answers, we have 0 equals x squared plus 1. Subtract 1 from both sides, and then we end up with the square root of -1. And we know what the square root of -1 equals. That equals I. So this situation, when we have two imaginary answers, plus or minus I, and two real solutions, plus or minus radical 6.